Before we get started, go through a few little housekeeping rules for our webinar. It is going to be recorded to share later, so those that did miss today's webinar, we will be able to watch it later. And also, the presenters will be shown on the screen with supporting presentation. In other words, you will not see all the other attendees today. We'll just see the presenters. And we will also get their slide deck, their PowerPoint, to share along with the webinar afterwards. Attendees will be allowed to post questions in either the Q&A feature. If you drop your Zoom bar either up or down, depending on where it's at, you can select the Q&A feature to type in questions. Or we'll also use the chat feature where we may ask you an impromptu question. The presenters may ask you something where you can dialogue with them through the chat feature. Any questions we take, we'll answer at the end. And also, we expect today's presentation to last no more than an hour, and we'll go from there. So before we get started, I would like to introduce our two speakers. Energy Logix have been fairly long-time members now for at least a couple of years in AAFAME, very involved in our training committees, our educational offerings. So we're very excited to have them here today to teach this webinar. And I'll introduce the speakers. Brandon Clark. He comes to Energy Logix with a unique and vast background in HVAC industry. We were just talking a little bit about his background before we started this webinar this morning. He brings over 10 years of experience in industrial water treatment of condenser water systems and another 16 years of HVAC mechanical system service sales, with an emphasis on healthcare, industrial, tech markets, office markets, and such. He serves on our training committee and is very good at building houses for us at Community First. Thank goodness he was there that day to help us, or we would have been living in one of those houses overnight. So thank you, Brandon, for your involvement. Joining us also is Jeff O'Day, who brings 20 years of sales experience from also with Energy Logix. And his background spans working with everyone from Fortune 500 companies to single employee organizations. And so without further ado, I'm going to switch the screen over and let them two start our program.
Good morning, everybody. Thank you for joining us. We really appreciate your time and your interest. I'm going to reiterate what Amy said about retrocommissioning, recommissioning process being a very understood component that is probably one of the most impactful things that you as a facility engineer can do for your building. And I hope that before this hour is over, that you all will see the benefits. You'll see if your facility is a good candidate for retrocommissioning or recommissioning, and you'll understand what that process is going to look like and how you get there if you do have interest. So we'll go ahead and start up with our slide. The presentation, I usually use analogies for my customers related to something that they commonly understand, and that's vehicles. And you know, we talk about vacations. Now you can't go to Cancun or Cozumel. You've got to take a trip to Port Aransas. If you're going to go to Montana on a vacation right now, what's one of the first things that you're going to do? You're going to get your vehicle over to the mechanic and you're going to ask them, hey, go through everything and take a look at the belts, brakes, hoses, make sure that you're going to get to that destination and back safely with your family. So the same process, it takes place with your buildings. So move on to the next slide. A little quick introduction to myself. Amy already introduced me. I've been with Energy Logix for 2 years. I'm new to the Austin market, but I've been in San Antonio in the HVAC industry for 28 years. I love what I do in account management. And I really love developing solutions that are in the best interest of our customers. And so I take great pride in this presentation and you giving us your time to learn about this subject. I'll introduce Jeff O'Day.
Yes, hi, my name is Jeff O'Day, also with Energy Logix. Amy has already gone through and done a brief introduction. Really what I like to add is we're here to be an ally. We're here to be a tool. We're here to help you get to where you want to be. You know, really it's about the end result, and not the end result that we think is important for you, but the end result that you feel is important to you. We're here to guide you. We're here to educate, and we're here to really make this town, you know, the best it can be.
All right, everybody. I hope you're familiar with Zoom and the Q&A, the chat. Don't be afraid to use it. That's why Jeff and I are both working on this presentation together, so that we can answer any questions. We want this to be specific to each and everybody that's a part of this. So I'll go on to explain a little bit about Energy Logix. This is not a sales presentation by any means. Just tell you a little bit about what we do. We are a full service mechanical contractor. We work on chillers, central plants, packaged equipment, boilers, generators. We provide facility solutions. We do a lot with healthcare, office buildings, tech centers, and we try to encompass the entire envelope of a building as it applies to the best interest of the customer. So we'll move on to explain about retrocommissioning and recommissioning. You've probably heard those terms, but what is the difference between the two? Commissioning is a process that it's a requirement by certain standards of buildings these days, that if your building is, if you have a total mechanical equipment cooling capacity that's greater than 40 tons, by code, you have to have building commissioning on new construction. A lot of facilities were built before that code was implemented, so they didn't undergo a commissioning process, and that commissioning process is to ensure that the building was constructed in a way that the mechanical engineer actually designed it to be done. So you'll have the owners involved in the building process, general contractors involved in the process, and then your mechanicals, electrical, and plumbing contractors. But who is actually making sure that it's being done properly? And that's when a commissioning agent comes in. So if a facility is supposed to have 40 tons of cooling, is that 40 tons of cooling getting where it needs to get? Recommissioning, that's for facilities. It's pretty clear. It's for facilities that were originally commissioned in new construction, but it's time to do it again. It's just like that tune-up on a vehicle. Retrocommissioning applies to buildings that never had an original commissioning, but would greatly benefit from a commissioning process. And that's where, whether it's a recommissioning or a retrocommissioning, we're going to show you some key components of how you identify whether your facility is a candidate for either one. I would say, as a general rule of thumb, the answer is yes, if you're asking yourself if you would benefit from a retrocommissioning project. And retrocommissioning can mean a lot of things, and we're going to go into that. So the next slide, Jeff. So we're going to discuss today the why, the who, the when, and the how. And this is the definition of retrocommissioning. It's the process that seeks to improve how a building's equipment and systems function together. Depending on the age of the building, retrocommissioning can often resolve problems that occurred during design and construction, or address problems that have developed throughout the building's life. Retrocommissioning involves a total building envelope evaluation to improve energy efficiency. That being said, by definition, it can also be as small or as large of a project as you want it to be. It doesn't have to be whole encompassing, but you're going to see throughout this slideshow that to realize the full benefits of a retrocommissioning project, you should encompass the entire building's HVAC system. So why? Going beyond the obvious things here that or on the presentation is customer tenant satisfaction through improved comfort. You guys are the front line. You guys know that when a tenant is uncomfortable in their space, you guys are going to know about it first. It's also going to be reduction in unscheduled shutdowns and repairs. You're going to help eliminate the surprised bearing failures, all types of mechanical failures and electrical failures. You're going to improve building performance, energy efficiency, and indoor air quality. And I'm going to just briefly discuss real quick is indoor air quality is becoming a more and more important topic, as we all know, in the year 2020. So here, this slide and this pie chart, 63% of energy deficiencies are related to HVAC. That's a huge chunk of your bills that are going out the window because these are deficiencies. So if you can correct these deficiencies by identifying them and taking corrective action, then you're going to save yourself money. You're going to be putting money in your pocket. The interesting thing about this pie chart, if you'll notice, is that the air handling and distribution is 37% of these deficiencies, and your cooling plant is only 11%. So many times we focus a lot of our attention on maintenance and energy efficiency within the central plant, and we ignore the airside distribution. And obviously, by the results of this pie chart, that's where we need to start focusing more of our attention is on the airside and distribution.
So to add on here, Brandon, what I've also found to be interesting was two other items on this pie chart. One, the envelope of the building. You know, a lot of times people are really concerned about the air escaping. Envelope was 0.1%. And then the other thing was the other slide. So, you know, the only one that's even close to air distribution and handling would be the other. And that's really, you know, all of the tenants, all of the people you have in there, all the horrible, wasteful stuff they can do with energy. And we all know they do, you know, they leave their computers on 24 hours a day, 7 days a week. They're not in there working on a Sunday, but their computer's still on, still using energy. And all of those combined still don't touch what you're losing in air handling and distribution.
So the project itself, here's another why is money. You can advance the slide. So retrocommissioning an existing facility has shown a median cost of 27 cents per square foot. The influencers on this cost per square foot are how large of a project you decide to tackle. Are you going to focus on your central plant? Are you going to look at the air side? Are you going to look at your controls, lighting, fire alarm system, building envelope? All of those can be encompassed into a retrocommissioning project. But we're here to focus on the thing that saves you the most money, and that's your HVAC system. You generally have energy savings of greater than 15%, and that statistic is from the U.S. Energy Star website. And based upon my own experience, you oftentimes get over and above 20% savings on your overall utility spend. That's a significant amount of dollars. And then the simple payback on a retrocommissioning is as little as 0.7 years. That is something that any CFO, any financial person is going to look at that project and they're going to sign off on it.
Yeah, that simple payback, I mean, just to put it in perspective, if you were to, you know, complete this process today, that means your simple payback would occur by Friday, March 5th, 2021.
All right, so who and when? If you have a building that is generally older than 15 years, you're probably a very good candidate for a retrocommissioning project. Here are some things to take into consideration. Has any significant changes occurred in the building for your occupancy, space utilization, equipment configuration, or maintenance practices. When energy use trending reveals an increase over time, why are you using more kW per hour at your facility? An older building where no commissioning data originally exists, and then the more complex your building, the more important the retrocommissioning process is. Take into consideration a facility that's 15 years old. How many times has your space been remodeled by your tenants? What all was taken into consideration? Were there design changes for your HVAC system? Are they moving ductwork? Are they replacing equipment? Were they taking into consideration the original design compared to what they're doing compared to future use? And so oftentimes we see there's a lot of money being spent on facilities. We're not catching the things that on the design process later on. So, Jeff, you want to go ahead and put that into perspective for us?
Sorry about that. I was on mute. So what we find is, we go ahead and we build these buildings. We move tenants into them. Life goes on. Well, the buildings are aging. We know that. And really want to put this into perspective. So we're going to go back a little bit here and look at some things that were happening when some of these buildings were completed. So what we have here is we have the year 1986. That was the year 301 Congress was completed. At that time, the #1 movie in America, that was Top Gun. You're paying 86 cents for a gallon of gas, and people were running outside, joining hands, and Hands Across America was in full swing. That's the year, like I said, 301 Congress was created. During that time, lots of things have changed. This was top of the line telecommunications equipment in 1986, the old bag phone. This is what your desktop computer looked like. And as these buildings age, what components are still there. You wouldn't still use the old IBM computer to handle, sharing information. It's not efficient. I mean, at its time when it was built, it was the most efficient way to do that. The building's the same way. When it was built to the top standards of efficiencies, but those have changed. And what's really, I find to be rather telling is how really quickly this can happen. When I look at the next slide here, so the next slide, it's the Frost Bank building. I feel like I was already old when that building was created, was finished. It was the year 2014. The #1 movie in America was Shrek 2. I took my kids to that. This still seems really recent. Gas, $2.10 a gallon. And most importantly, I feel the Red Sox ended the curse. Again, that's also the year when Frost was completed. But this is what this was your top of the line telecommunication equipment, the Motorola Razor. You could make phone calls, you could receive phone calls, you had a little tiny color display. You didn't have the amount of information at your fingertips that you have now, where you can get on and, I get on my iPhone and I can see everything that was ever done really in the world, instantaneous. Your computer, again, we wouldn't use this equipment anymore. And it's really amazing to me, or not amazing, but it always surprises me on how quick the hands of time really catch up. I said it was, if before I looked into it, if you asked me how long ago the Frost building was built, that's new, a few years ago. No, if it was a kid, it could drive. And it's, what's happened during that time? How many tenants have come in and out? How many times has, someone thought they were helping with something where they went and, maybe manually changed a setting on something and didn't change it back. It's had 16 years of life happening inside it. And you can't be certain that it's still operating at the high level it was designed to operate at. Brandon?
So obviously, you guys, I know that you're familiar with both of those facilities. I would say, really without knowing that much about the buildings, they are likely very good candidates just based upon their age alone. And so we're going to talk about how you go about the process. It's retrocommissioning. It's a 4-step process: planning, investigation, implementation, and handoff. Planning being, I think, one of the most important phases to the retrocommissioning process. It's where you're going to sit down with somebody that has experience in the retrocommissioning environment, and you're going to discuss the building's needs, the building's uses. You want to find out how the building was designed, what was it designed for, what's changed. So you take into account the building's energy efficiency, any comfort issues with specific zones, tenants, if you're having repeated callbacks, if their work orders are stacking up on a certain piece of equipment, if you're not getting the full life cycle out of your equipment, that's an important consideration. Indoor air quality, are you having issues with comfort in spaces and your customers are complaining about headaches? Are you seeing microbiological growth in air handlers? What's causing it? Changes in building function, that goes back to what I said earlier about tenants move in and out of our facilities constantly. Are they using the buildings and their spaces as they were originally designed? And then are you getting feedback from your tenant? It's going to be important during the planning phase that you involve your tenants in the process so that they feel like they have a little bit of feedback from us when it's all said and done.
Just to add on to that, Braden, the other thing is, changes in the building function. What the tenant is using their space for, the perceived value of their square footage. Came across a statistic when we were putting this together. It's a BOMA statistic, but it still lends itself really well to what we're talking about here. And that's that 40% of leased space will be co-working / flex space by 2030.
That's a very good point, Jeff. That the environment for our office spaces is changing, as you guys well know that. The co-working environment, WeWork, is a very popular type of rental space for customers these days. And so is your building designed for that co-working environment? If not, are you trying to use it as the building was designed and just make it work? What needs to be done to prepare for that? And if 40% of your leased space is going to be that co-working environment in 2030, now's the time to be having those discussions with your facility owners and property managers, as well as your vendors. So the investigation process is the second step in a retrocommissioning project. You're going to look into how do you fund the project. Obviously, there's a payback period. There's going to be financial benefits, but it's going to take money to get to that point. So here you're going to find out what areas, what tenant space, what equipment are we going to focus on as part of this retrocommissioning. We're going to gather any as-built drawings, test and balance reports, original design specification drawings, control sequence of operation. We really like to get the previous 2 years of utility use. And then if you have a work order system, and we can go through and evaluate any specific areas that you're repeatedly having to respond to repairs. We're going to take all that into consideration in where we're going to focus your money and our time. Funding mechanisms, there are, and I know that this has been taught as part of the AAFAME program. We had the director of the Texas PACE Authority at one of our luncheons and gave a talk. And I know that when you start talking about projects, it really sometimes makes engineers cringe because it sounds like a lot of work. But the way that this works is it's going to be a lot of work maybe, but in the end, the grand scheme of things, it's going to make your life a whole lot easier. Part of the investigation is providing a building assessment and a walkthrough. It's going to require somebody with experience, whoever your HVAC vendor is, or a commissioning agent. They can sit down with you after the planning phase and then prepare a building assessment. That assessment's going to look like it's going to evaluate everything from your central plant up to down to your fan terminal units, your VAVs, and it's going to take all that into consideration. That's when you're going to look at the age of the equipment and the overall condition and how it affects your entire system. You're going to look at rebates. What's your local utility program offering for rebates? We work with Austin Energy and then other utility providers to make sure that we're getting those benefits. And then during the process of retrocommissioning, you're taking a deep dive into your HVAC system, your lighting system, your generator. You're gonna come across problems and deficiencies. So what are you gonna do while you've got people there doing this evaluation and testing? You need to be prepared that they're gonna find some deficiencies, defects, and those corrective actions that are going to be recommended. How are you going to handle those? So you're going to have to budget for that as well. And whoever's working with you to do the retrocommissioning, they should be able to help you with that up front in the planning and investigation phase. And then, like any project, you're going to set goals. Like, what do we want to accomplish here? Is our primary objective tenant comfort? Is it for performance of the system, or is it to prepare the building for increase its valuation? So on the implementation side, where did the investigation lead you? What did you find during your building assessment? If you find so how many times does a facility assistant engineer, you might be out of the office as the primary engineer, assistant is there, he's responding to a cold or hot call. He may not completely understand the building automation system or the functionality of an actuator or a control device. And so he may manually lock out or throttle down a valve. He just responded in the best way he knew how. But that problem is solved until the weather outside changes, and then it's going to rear its head maybe 9 months later when the heating season comes around. It may not ever rear its head because you may have multiple systems feeding a space and it's able to overcome it. But now all of a sudden you're driving your vehicle with your foot on the throttle and the gas at the same time. It's costing you energy dollars. You're going to talk about in the implementation who's going to be involved. Generally, you're going to have your commissioning agent is going to be involved in the process. The facility engineer is a very important part of this puzzle. Oftentimes, the facilities engineering group, they know more about that facility than anybody else. So it's going to be important to get their feedback throughout the process. And then obviously the funding and execution is going to be discussed ahead of time. So after the after the retro commissioning phase is done, you're going to hand it off to the facility owner and operator, the engineers. Any test and balance reports that were a part of the retro commissioning process, they're going to be in your hands. It's going to be a great value and benefit to you, because a lot of times you guys don't have that information. Same thing with as-built drawings. And each retro commissioning process does not have to include test and balance reports, drawings, sequence of operations, measurement and verification. The thing about retro commissioning, if you learn anything today, it should be that each building is different and each facility's needs are different. So it has to be tailored specific to what your needs are. So you'd obviously, the worst thing you can do after a retro commissioning is let it fall back into the condition that it was prior to the recommissioning. So the how. Building assessment, you're going to gather data, get all the information up front. If you'll look at this pie chart, operations and controls is 72%. We oftentimes find that my example of the person overriding the building automation system by manually pinching down a valve, it has a great effect on the overall efficiency and the operation of the building. So you come back as a facility engineer, your assistant made that changes to the valves. He doesn't necessarily tell you, and you're left to find it later on. And oftentimes we have to rely on stumbling on it or a customer complaint before we actually find it. Also, how many times does a building engineers, how many times do you change buildings? It's very rare to have somebody long-term at one specific building. And so every engineer may come in there and manually adjust things on their own, which will have an impact on the overall performance of the building. So understanding the building energy use profile and identify the energy consuming equipment. We want to look at those utility bills over the last 2 years. If we can identify any spikes, either via calendar year or related to specific times of the day, that's important to take into consideration. Then you'll start investigating where you need to implement changes in that, if changes are available. Then you're going to determine the facility's consumption and usage based upon the current needs, and you're going to compare that to facilities of similar size. Austin Energy, they have the dashboard that you can, if you're not taking advantage of that, you may very well benefit from that. I believe that's a great program. And then it needs to be discussed with the facility engineer as well as the property management and the owners. What's the design for the building's future? What are your expectations for the building to do as compared to how it was originally built or how it's being used today? So taking into consideration that if it's going to be 40% of your workspace is going to be at a co-working environment, that needs to be taken into consideration. And I'll discuss quickly, I saw that Marshall asked a question, and when replacing a building's air handlers, would it be beneficial to complete a recommissioning before, or should the process be held off until the unit replacement is complete? It seems there might be some benefits to complete this prior to the project to assist in identifying a replacement unit. And that's absolutely a great question, Marshall. That is a very valid point that you would absolutely, I would take into consideration a recommissioning, retro commissioning before changing out that air handler, because there's so many things that need to be taken into consideration in that change out. There's different standards today, depending on the age of that original air handler and that building. There's different standards today for indoor air quality, air changes per hour, and then also space comfort for your tenants. What is the use of that space? How is it being used today, and what do you want it to do in the future? All those things need to be taken into consideration as opposed to just, if you've got a 50,000 CFM air handler with a chill water coil and a hot water coil in a reheat position, is that the best application for you? Don't just, you'd be doing yourself a disservice by just simply changing it out with exactly what you have without taking the time to identify what those answers are to those questions. Again, this speaks to, it doesn't necessarily have to entail a total recommissioning or retrocommissioning in order to take that into consideration. That can be on a specific basis for that one air handler. However, overall, if there's multiple air handlers on that floor or in that zone, you might take into consideration how that's used specifically for that entire area and how it relates to other air handlers that you're not replacing at the moment. I hope that answered your question. If it didn't, feel free to touch base, and we'll review all these questions and go over them. So understanding the building's energy use profile, this is, where's your money going? So cooling, heating, ventilation make up 44% of your building's energy consumption. That's a significant amount of your annual spend. Office equipment, your fax machines, computers, your servers, all of that makes up 26%. Cooling is obviously the largest at 29%. And then lighting is another one. I think a lot of people have already completed lighting retrofit projects. LED versus the old T12s is a no-brainer. And if you haven't already incorporated that into your facilities, that can be a part of a retrocommissioning process as well. Understanding the building's equipment and systems, you're going to review the current as-built drawings if they're available. And as most of you know, that's a luxury. So you want to know, has this tenant space been remodeled? Are we using a certain zone in a different way? And is that reflected properly on the as-built drawings? Or does it differ? And if it does differ, why is it different than what the engineer originally designed it to be? And how is that impacting that area of your building and the overall operation and performance of your facility? Those are all important questions, but you're not going to be able to come up with answers until you do the investigation and you get as much information up front as possible by reviewing these documents. Sequence of operations on controls, that's a big one. That's all changed. Technology has changed tremendously in controls environment. There's still buildings around that have pneumatic controls. Even from a digital standpoint, there's been huge improvements even in the last 5 years. So if your control system is 10 years old, it's more than likely obsolete. So talk to the people that matter to obtain information about the HVAC system's history and current condition. That's you guys. That's the facility engineers. You're the ones that understand that equipment and how it's being used and how it's causing problems, or if it's not meeting your needs. And then here we talk about the building walkthrough and develop an informal assessment. So Jeff is going to talk a little bit about the specific things that you are going to accomplish during the retrocommissioning process and how it's going to help improve and give you that payback of that we're looking for.
Thank you, Brian. Yeah, the common tasks that we come across in controls in regards to retrocommissioning is optimizing zone temperature requirements. Every building's different, every space is different. This is also falls under what controls do your tenants actually have? Some places we find where they've really locked down what their tenants can do. Other places they have complete control over it. You know, are they using it right? Are their expectations in line? Have things been set and forgotten about and set correctly or incorrectly? Want to verify the actual zone conditions versus the design zone conditions, as well as reviewing the schedule of operations for suitable improvement. Some of the sample findings we find after conducting these tests are that the control sequences were functioning incorrectly, or that valves, dampers, etc., were inoperable, in bypass. You know, they were changed in hand, they're manually manipulated. One of the other big things that we find is, especially with tenant build-outs, you know, a lot of times it's function following form. So where are the thermostats? Where are they reading their temperatures from? Are they under a diffuser? Are they next to a window? Is it the common thing where, you know, the thermostat that controls, you know, Susie's office is located in Mike's office? You know, things like that. Is it in an area, you know, I've seen them in closets before, where there's no airflow, or there's something that's generating heat in there. So whoever's area it is that air is being provided to, they're freezing. They're in there wearing blankets in the middle of summer. You know, where is the equipment that the thermostat is controlling? And also, is the controller accurate? Come across this all the time. I was in a surgery center yesterday. They were having issues with the humidity in one of their operating rooms. The sensor on the wall said that they had a 75% humidity. When I manually tested the humidity in the room, it was actually at 52%. The only issue that was really happening there was that the sensor was wrong. The sensor is what controls everything. It's also where people look to see what something is. A lot of people aren't able to accurately tell, you know, exactly what the temperature is, what the humidity is based on feel. They look at a number, and what it says is the reality to them. Common tasks that we find in the central plant. So we're going to evaluate the chilled water set point, your gallons per minute in your flow, and make sure that it's in tune with requirements. We're going to evaluate the condition of the chillers, pumps, cooling tower by comparing what the design parameters were with what the actual parameters are. Are you still getting the efficiency that you are supposed to be getting? Is it performing as designed? Check pressure drops against your evaporator, your condenser, and your pumps for suitable improvements, as well as checking for short cycling in your water or air circuits. What we often find is things like your VFDs, your variable frequency drives, are operating at an unnecessarily high speed, or operating at a constant speed with a variable load, or they've been put in bypass. When any of those things happen, you know, the biggest thing you're going to get out of there is that they're just not operating as efficiently as possible. We have a slide coming up that talks about the power bands and the energy efficiency of that. And your VFDs fall really in the same place. If they're not operating where they're supposed to be, then they're costing you money. You know, the other thing is if it's operating in bypass, or if it's been, you know, manipulated by hand, at that point, what's the point of a VFD? If you're sitting there saying you're going to run at this percentage, you know, you've taken the whole point of it and all of the good things that a variable frequency drive provides to you, and you've nullified it. And it's not, you know, it's not done for any reason other than trying to fix a problem at hand. You know, I'm going to go ahead and I'm going to manually put the VFD to this position. I'm going to come back and I'm going to fix it, and then life happens and I forget about it. It's not intentional. It's not done with any malicious intent. it's done from a place of, I need to solve this problem right now. It's just a follow through, and it happens everywhere. So common tasks that we see in the air side. So we're going to evaluate all of your air handlers, including maintenance components and valves. That's going to really help us finding the problem children, if you will. Finding your pieces of equipment that are costing the most money. Also, it's going to help us to see, if this thing's been acting up really since inception, is it a case of, an engineer said, okay, this is going to work without fully understanding the space, or the space has changed and it's simply not the right piece for the application anymore. We're going to verify the design versus actual operating conditions on the air handling units, the VAVs in your FCUs. We're going to evaluate all of your airside VFDs. We're going to check all of your fan coil units, including the valves. That, I know we keep talking about this, but it's only because we see this a lot, where those valves have been manually manipulated, or they're hanging up, as well as your actuators, comparing what the design is to what the real world is. We're going to check out all the operation on your VAVs. We're also going to look at your duct layout, your diffusers, your grill, your conditions of them. During build outs, we, seen things where someone has cut a duct line because they're changing where the air distribution is. And they meant to go in there and put a cap on the end of the duct, but it didn't happen. So you're pouring this conditioned air that you're spending money on, and it's going into, a drop ceiling. You're not getting the dollars out of what you're putting into that.
Yeah, Jeff, to piggyback on that, remember the earlier slide where we pointed out that 37% of your deficiencies are in the air side. Your air handlers and your duct work and your fan terminal units, it's a huge component, a huge part of a retrocommissioning process. And that's really where you're going to find a lot of energy savings. And you've got to take a look at your valves, for instance. Part of the commissioning process is we have one person on the front end of your building automation system. They're going to drive open your actuators on your water side and air side for your dampers, and they're going to drive them open and close, and you're going to have somebody in that mechanical room verifying, is it indeed closing 100%? Is it opening 100%? If it's not doing those things, those are a big part of the reason that it's a 37% deficiency in your building. How are you going to know that unless you're checking it? That's where this comes into play, and the retrocommissioning process really saves you money. Also, doing a test and balance and checking your static pressure drops across your coils. If the design from that manufacturer of the air handler is 1.5 inch pressure drop across the coils, and you do a test and you find out with your MagnaHelix and you find out that it's at 2.5 inches, well, is that because you have impacted coils? What's causing that problem? But you identify the problem and you take corrective action. And those types of things, they pay for themselves extremely quickly in improved performance and savings in energy, but also in space comfort, indoor air quality, and tenant comfort.
So I know I was talking about the power band, and this is the slide I was talking about here. Really what is eye-opening here is that if you're at 80% of full speed, you're using 50% roughly of your power. As you go above that, if you're at 100% speed, you're using 100% input power. You're paying a lot. Where if you're 20% 20% down on your full speed, you're saving half. And this is a huge one where we can go through and say, all right, where have these things been changed to where they're not operating where they should? This is where, when we're able to make changes like this, that's money right in your pocket right away. And then the common tasks we see on the water side, we're going to look at the cooling tower, the chiller, pumps, maintenance, valves. We're talking about the coils a lot and the valves in your fan coil units, especially on the water side, any sort of solids you have in there, they have a tendency that they're going to get hung up and they're going to stop right at those valves. So as those valves are actuating, 100% open to 100% closed, they can't get there. There's debris and it's stopping them. It's impacting the performance of them. Also checking things like your water treatment, checking your strainers. When was the last time the water side was closed? Do you have any dead legs, pressure drops? Clogged strainers and valves that aren't functioning properly are going to impact you, every day. And getting those cleaned out, getting those taken care of are small dollars that'll instantly put money back into the building.
Yeah, so here we're going to reiterate and we're wrapping things up here. And it's the benefits, obviously it's about money. It's about space comfort. It's about happy tenants. But we're also going to increase the value of the facility. There's a lot of benefits outside of the obvious ones. And I'll tell you briefly how I got into the retrocommissioning, recommissioning. I was your typical sales guy in the HVAC market for a mechanical contractor. I was in San Antonio market. It was the Westin La Cantera Resort. There was a new facility director that came in from Arizona. I was sitting in his office getting to know him. He's in the engineering departments in the basement. He's got guys calling him on his radio, calling him on his phone, poking their heads in the office. And he and I aren't able to carry a conversation on because he's being interrupted constantly. Well, it was kind of a light bulb moment for me. And I realized like this guy, it's Westin La Cantera Resort is a large facility. He's got all kinds of problems. And I think I could see how he was overwhelmed and his staff was overwhelmed also. I knew that I needed to do something to help him. So that was when I offered to do a walkthrough and a building facility assessment. I put together that report and then I identified some things that we could do, retrocommissioning be the biggest one, to help improve the facility and eliminate those problems. And so we implemented a retrocommissioning project. We set aside some monies to handle replacing things the deficiencies that we found during the process. And then we managed to save Westin La Cantera Resort over 20% on their annual spend for their utilities, which was a significant amount of savings that they were able to apply to other things that they needed for capital projects or facility improvements. And then Terra Resort was owned by Starwood Properties, and they asked me to start doing retrocommissionings for all their properties. So once your building owners, CFOs, the financial people, they see the results of this, they are absolutely 100% on board with this process. So your cost benefit analysis, again, it's that overall savings is 15 to 20%. Your payback ranges from 0.2 to 2.1 years. That range varies depending on how far you want to go into it, how deep of a dive you want to take into your building. And then lastly, not all energy is bad. Energy consumption is part of what we do. It's part of the business, but energy inefficiency is bad. And so if you don't stumble on these things, how are you going to know if you've got deficiencies unless you actually take the time to go in and have a process, and that retrocommissioning is your process. So I'll go ahead and wrap things up. We're looking at going at right at an hour now. we greatly appreciate your time. And Marshall, thank you for your question. Anybody else have any questions, feel free to ask us. We can answer questions specific to your facility